Alright, so we can basically use ratios to compare quantities of the same kind. So you might have heard people use ratios in a number of different contexts before. They give an example here. They have 5 apples and 4 oranges drawn. So the ratio of apples to oranges is 5 to 4. So it's a way of comparing the quantities of the different kinds of fruit. Ratios, whenever you're writing a ratio, you don't include any units. So it is a unitless type of way of representing data. A ratio is, you would have seen ratios before, it's when we use a colon. So if we have, say, 5 to 4, you always have the colon in between the two numbers. That's what a ratio looks like. So remember, when using ratios, numbers and categories need to be in the same order. On the previous slide, the ratio of blue to yellow circles was 3 to 1. So yeah, if I was saying blue to yellow, since we're talking about the blues first, you say the 3 first and then the 1 second. If you were saying the ratio of yellow to blue, then you would say 1 to 3. So before ratios are written, the numbers must be expressed in the same units of measurement. So see how originally in this example it says 7 millimeters to 1 centimeter. That's no good because we're comparing millimeters to centimeters. You need to either convert the centimeters into millimeters or millimeters into centimeters, so then they're of the same unit. So they converted 1 centimeter into 10 millimeters. Then once they're in the same units, we can write a ratio 7 to 10. Then we can, like we practice with fractions and simplifying fractions, we can also simplify ratios. So if we have a ratio of 30 to 15, in the same way that we simplified fractions, you look for a common factor and you can divide by that common factor. So here, can you see that they've divided by a common factor of what to get to 6 to 3 from 30 to 15? 5. Alright. Now, the other thing is, when we're writing a ratio in its simplest form, you can't leave it as a fraction. It always needs to be written as a whole number, a ratio in its simplest form. So here they started off with 30 over 100 to 15 over 100. To get rid of those hundreds at the bottom, what did they do to both sides of the ratio? How did they go from here to here? They've multiplied by 100. And then once they've multiplied by 100, again, like I said, they divided by 5 to simplify to this ratio. So it's similar to what we did with the top and bottom of a fraction, how you have to multiply by the same number or divide by the same number to simplify it. And the simplest ratio will never be written in a fraction form. It will always be written in terms of a whole number. So we'll have a go at writing a few ratios. So if I was to look at this shape here, and I wanted to write the number of shaded sections to the number of non-shaded sections as a ratio. So remember, whatever's stated first is going to be the first, so it's going to be on the left-hand side of the ratio. Whatever stated second is going to be on the right-hand side. So since they've said the number of shaded sections, that goes on the left, and the non-shaded sections are going to be on the right. So in this situation, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I count that right. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 shaded. So I'd start off by writing 17 colon, and then because we're comparing shaded to non-shaded, there's 1, 2, 3, 4, 5, 6, 7, 8. So an 8 would go on that side of the ratio. Similar to fractions, if we could simplify this, we'd be looking for a common factor to divide both sides by. Is there any common factor that I can divide each side of that ratio by? No, therefore 17 to 8 will be as simple as the ratio can be. Then part 2 asks to write the number of non-shaded sections to the total number of sections as a fraction. So can you see the difference compared to what part 1 said? Part 1 said the number of shaded to number of non-shaded, whereas part 2 says the number of non-shaded sections to the total number of sections. So we have to look at how many are non-shaded. 1, 2, 3, 4, 5, 6, 7, 8, compared to the total number of boxes. So since it is 5 across and 5 down, how many total boxes will there be? 25. And they want us to write this one as a fraction. So the fraction of non-shaded to total would be 8 over 25. 8 over 25. Alright, I want you guys to have a go at doing B and C. So same thing, you're going to do the number of shaded sections to the number of non-shaded sections first as a ratio, and then in part B, you're going to do the number of non-shaded sections to the total number of sections as a fraction. Alright, so I'll give you 2 minutes to do that. I'll pause the recording. So in part B, again, we're doing shaded to non-shaded as a ratio. So we've got 1, 2, 3, 4, 5, 6, 7 shaded. So 7 will go on the left-hand side of the ratio, colon. And then how many non-shadeds do I have? 3 plus 4 is 7, plus another 4 is 11. So you should have had 7 to 11 as your ratio of shaded to non-shaded. And then part 2 wanted us to do non-shaded compared to the total number as a fraction. So the non-shaded is, again, 7. And then the total number we have is 18. So you should have had 7 over 18. Is that what you guys got? Yep, non-shaded. Sorry, so it's 11 over 18. I was just making sure that you guys were paying attention. You guys passed the test. Alright, and then part C1, again, shaded to non-shaded. Shaded is 1, 2, 3, 4, 5. Compared to non-shaded, 1, 2, 3, 4, 5, 4. Now, again, with any of these ratios, we could multiply, if I multiplied both sides by 2, 10 to 8 is the same ratio as 5 to 4. Alright, so you can do that with ratios. And then part 2, we want non-shaded to total number. So non-shaded, 1, 2, 3, 4 over the total amount, which was 9. 4 over 9. So any questions about any of those? Alright, continuing on to the next one that I want to go through. Sorry, we might just quickly watch this video.
Hi, welcome to Math Antics. In this lesson, we're going to learn about ratios. Well, what in the world's a ratio? Well, let's look it up in a math book to find out. It says here that a ratio is a comparison of two numbers by division. Well, that's true, but it's also a little confusing. It's confusing because most of us think of comparing numbers as trying to decide if a number is greater than, less than, or equal to another number. But with ratios, we're not trying to compare numbers like that. Instead, we're really trying to see how two numbers relate to each other. And so at Math Antics, we like to think of ratios as a relationship between two numbers by division. Okay, but how do you compare or show how two numbers are related by division? Well, to see what the by division part really means, let's look at an example of a ratio. Excuse me, that's not a ratio, that's a fraction. Oh, it's a ratio all right. Mathematically, ratios and fractions are basically the same thing. It's just that when we use a fraction in a particular way, we call it a ratio. Well, sure, everybody knows that. Well, like I was saying, Ratios are basically just like fractions. The difference is how we use them to describe things in the real world. To see what I mean, let's look at examples of how we could use the fraction 1 over 2 and the ratio 1 over 2. Mathematically, these are both the same thing. They're just the division problem, 1 divided by 2. But in the case of the fraction, we usually treat it as if it's just a single number. For example, at lunchtime, you might eat 1 sandwich, or if you're really hungry, you might eat 2 sandwiches, but if you're not very hungry, you might just have half a sandwich. We can use the fraction 1/2, just like we use 1 or 2 to show how many sandwiches you eat. It's just that in the case of 1/2, we know that it's only part of a sandwich, just a fraction of one. Now let's see how we can use the ratio 1 over 2. With the ratio, we don't treat it as if it's just a single number. Instead, we pay close attention to the top and bottom numbers because we use them to refer to different things. For example, let's say we're planning to go on a picnic, and for every 2 people that are going on the picnic, we're only bringing 1 sandwich. In that case, we'd say that the ratio of sandwiches to people is 1 to 2, or 1 sandwich per 2 people. Do you see the difference between our fraction and our ratio? The math part of each of them is the same. But with the fraction, both the top and bottom numbers are referring to the same thing, the sandwich. However, with the ratio, the top and bottom numbers are referring to different things, sandwiches and people. The fraction shows a part of something, but the ratio shows a relationship or a comparison between 2 different things. And you can see that they're the same thing mathematically, because if you did have the ratio of 1 sandwich for every 2 people on a picnic, guess how much of a sandwich each person would get? Yep, half a sandwich. Alright, so now you know that fractions and ratios are basically the same thing. But since they're used differently in math, sometimes they're also shown differently. Once in a while, instead of seeing the standard division form, a ratio might be represented with this symbol. When you see a ratio written this way, it just means 1 to 2 or 1 per 2. For example, in this picture, you could say that the ratio of dogs to cats is 3 to 2. 3 dogs to 2 cats. And you could also write it in the standard division form. 3 dogs over 2 cats. They're just different ways to write the same ratio. Ratios are used all the time to represent all sorts of things in real-world situations. So let's see a few more examples to help you really understand what ratios are. Have you ever wanted to compare apples to oranges, but someone told you couldn't? Well, you can with a ratio. Now let's say a fruit stand sells 5 apples for every 3 oranges they sell. The ratio of apples to oranges would be 5 to 3. Or, have you ever helped someone bake cookies? The recipe might tell you that for every 2 cups of flour, you need 1 cup of sugar. That means that the ratio of flour to sugar is 2 to 1. Or, what about your TV screen or your computer monitor? Have you ever heard someone say that the size or aspect ratio is 16 to 9? 16 to 9 is the ratio of the screen's width to its height. So if the screen is 16 inches wide, then its height would be 9 inches tall. Here's another good ratio that you might use in your car. 40 miles per hour. Aha! Didn't you say that a ratio was a relationship between 2 numbers? But 40 miles per hour is just 1 number. Looks like someone's got some explaining to do. Actually, there are 2 numbers. Do you remember how any number can be written like a fraction, just by writing 1 as the bottom number? Well, 40 miles per hour is the ratio 40 miles per 1 hour. Well, I guess you have an answer for everything, don't you? 40 miles per 1 hour is a type of ratio that we call a rate. A rate is just a ratio that usually involves a period of time. Here are some common examples of rates. 10 meters per second, $12 per hour, 3 meals per day, 50 games per year.
Alright, we'll leave it there because we're not actually going to look at rates today, but at least he's given you a quick introduction to what a rate is also. Alright, so if we were to write some of these as a ratio, so if I was to write 95 kilograms to 57 kilograms, I think we're getting the hang of this. So this is 3B. 95 kilograms to 57 kilograms. As a ratio would be 95 colon 57, and then you could look to simplify it by finding a common factor and dividing by it. In this case, I don't believe that there is a common factor, therefore that would be as simple as we could write that ratio. And just one more example. Let's have a look at question. So, in this example here, we want to write a comparison of 13 seconds to 3 minutes. Now remember what I said about the units, they have to be the same. So if you were to do that, if you want to write a ratio here, you'd have to convert either the minutes into seconds or the seconds into the minutes. They've converted 3 minutes into seconds. Because we know there's 60 seconds in a minute, 3 minutes is 180 seconds. So therefore the ratio of 13 seconds to 3 minutes is 13 to 180. And we will leave that there. So you guys are going to just work through these ones here. Now most of them are pretty quick. Like you just saw me do an example from question 3 when we did 95 kilograms to 57 kilograms, just running that ratio really quick. So just try and work through them relatively quickly, please.